We can use the same circuits to demodulate the double sideband suppressed carrier. But of course, at the output of any demodulator, we have a low pass filter instead of a band pass filter. And the bandwidth when we demodulate is not 2B, it's going to be B. Remember that in demodulation we get back our original bandwidth and our original signal. So the same circuit can be used for switching or nonlinear devices, but the output should be a low pass filter and the bandwidth should be B. In all of these cases, if you want to demodulate, you need to multiply by a carrier cosine, which is exactly the same phase, same frequency. Okay, it has to be synchronized with the incoming carrier. It has to be synchronized. This type of demodulation is therefore called coherent or synchronized. If the demodulation requires you to multiply by C, which is exactly the same phase, same frequency, we call it coherent or synchronous demodulation. Of course, this is not something easy to do, and we'll see how things will work out. Finally, we would like to give an example. We'd like you to analyze the following circuit as this bridge as a demodulator. The moment it says a demodulator, we know we have here a low pass filter. So we have M here, okay, we have M here, and then this is going to work like a Fourier series, multiplying by this Fourier series. So we want the output to be the input now, because we are going to use the demodulator, the input is going to be M of t times cosine omega ct times W. This is the green part, huh? This is the equivalence of multiplying by the series. And then we have, we can open the bracket, we get the cosine squared. From other terms, of course, are all there. But I am interested in finding, I would like to get the message back. The only way I can get the message back is through this cosine square, because the cosine square, remember, it can be translated into 1/2 times 1/2 plus cosine double angle, from which we get what we want. Through the low pass filter, we get the objective term. Once more, remember that scaling is not a distortion. Thank you.